Hello students, I am Professor Pooja Paratne from Modern College, Pune. In this lecture, we will study the basics which we need to learn interpolating techniques in numerical analysis. In numerical interpolation, we will study first functions, then equidistant points, that is value of x and the corresponding value of the function, and difference operators. To learn interpolation, first we need to define a function. Now what is a function? A function is a relation from one set to another set. So which are these sets? So these sets can be any sets. Basically the initial functions, initially we should have the function as f from a to b. F from a to b means here we are taking some elements of a, then we are defining some formula under the function f, and then whatever we will get the result, that value will be in b. Generally we define fx equal to y. We write f of x. So do not read it as fx. It is f of x equal to y, where x belongs to the first set A, which is called domain, and the second set B, which is called codomain. Here this set B is also called image set. For example, we will define one function. So let function f, we will take the function f from A to B. Here both of the sets we have taken as z. Z is set of integers. Integers everybody knows because we have all those three standard sets, set of natural numbers, integers, then whole numbers, etc. etc. So here I have written the set z. Let us define the function fx equal to 2x. Here this is a definition of a function. Definition means what? The formula for this function. Then what is the formula for this function? It is 2 into x. So let us see how we can find value of the function at various values of x. So here I have taken as an example some 4 values. Let x equal to 1. So wherever there is x in the definition of this fx, we will put x equal to 1, that is 1 there. So f of 1 equal to now 2 into 1 because we have the formula as 2 into x. So we will put 2 into 1 equal to 2. Similarly, when x equal to 2, put x equal to 2 in the formula of this function. So here f of 2 equal to 2 into 2 because we have the function as 2 into x. This is equals to 4. So next value x equal to minus 3. So let us take f of minus 3. X is there. So we are writing here f x equal to minus 3. And then in the formula we will put x equal to minus 3. So whenever there is negative value, please put it in the bracket so that the sign mistake will not be there while multiplication or addition or subtraction. So here the answer is 2 into minus 3. And when we multiply one positive number and one negative number, we get always the negative number. So answer is minus 6. Next value we have taken x equals to 0. So putting value x equals to 0 in this formula, f of 0 equal to 2 into 0 is 0. So that is f of 0 is equals to 0. So now if you observe here, we have taken 4 values as an example. 1, 2, minus 3, 0. And at the corresponding, that is when corresponding values of this x, that is when x equals to 1, we are getting value of f of 1 equal to 2. When x equals to 2, we are getting value of f of 2 equal to 4. When x equals to minus 3, we are getting value of f of minus 3 equal to minus 6. When x equals to 0, we are getting f of 0 equals to 0. So these numbers 2, 4, minus 6, 0, these are called images of the elements 1, 2, minus 3, 0 respectively. That's what B is also called the image set. Let us take another example. So let A, I have defined a proper set taking some elements, A containing the elements 0, 2, 3, 2.5, minus 1.2, 51. And here I have given the function fx equal to x square plus 2x minus 4. So this is the definition of a function, that is formula for the function. Let us find images of all the elements from the set A. Consider x equals to 0. So in the formula of fx, we will put x equals to 0 wherever there is x. So you can observe here that f of 0 equal to 0 square plus 2 into 0 minus 4. So 0 square is 0, 2 into 0 is also 0. So 0 plus 0 minus 4 equal to minus 4. So it means that image of x equals to 0 is minus 4. Similarly, next value x equals to 2. Here f of 2 equal to, again substituting x equals to 2 in the formula here, we are getting value as 4. For x equals to 3, same substituting value of x equals to 3 in the formula, we are getting f of 3 equal to 11. Calculating it same for the remaining values. Here I have taken one negative value here also. So when we have negative values, we have to take care of its signs. So check the calculations again to check whether your signs are correct or not. Because when we square the negative number, always we get the positive number. You can see here minus 1.2 minus 1.2 square, we are getting 1.44. The multiplication of negative number with negative number is always positive. So these are some rules of multiplication, that is multiplication of positive is positive, multiplication of negative is positive, multiplication of negative and positive is negative. You can see here, look at here 2 is there and into minus 1.2, and you are getting the multiplication as minus 2.4. minus 4. So that's what again I will suggest you to put the values in the bracket, negative values, especially whenever there are negative values, put them in the bracket so that we cannot admit any mistake. Calculating the value, you are getting it is a minus 4.96. Next value and last value is x equal to 51. So again same way, substituting x equal to 51 in the formula, we are getting the value 2699. Next concept is increment h. So what is h? H is an equal increment in x having some specific value. Specific value means whatever we will define, h equal to 1, h equal to 0.5, h equal to 0.2, any value, whatever we will define, or it is a given value. So if you have given h and if you have given the initial value of x, which is denoted by x0, then we can find the set of values of x by adding h successively in x0 or in the previous values. So here theoretically I have explained here. For example, initial value equal to x0, equal increment equal to h. These two values must be given. Without that we cannot find the set of values of x. So then the values of x are as follows. So first value we have x0, next value we say it is x1. Then what is x1? We have to add h to this initial value. So it is x0 plus h. Then next value is x2, we denote it by x2, which is x1 plus h. What is the previous value of x2? x1. So we will add h to x1. So x1 plus h. But what is x1? x1 is x0 plus h. So x0 plus h, which is value of x1. This is value of x1 plus this h. And answer is x0 plus 2h. So when there is x2, so here these are suffices, 0, 1, 2, 3, 4, these are suffices. We have to write at the bottom of x. So when there is suffix 2, multiple of h is 2. As we have taken initial value as x0. If we define it different, then you will not get here 2, but it is always we have to take initial value x0, especially in interpolation, and you also please take the initial value as x0 so that it will be easy to do calculations and use the results and formulas. Next value is suppose x3. Then what we have to do? Add it in the previous value x2, x2 plus h. Then what is x2? x2 is x0 plus 2h. Just now we have calculated it previously. So x0 plus 2h plus h. So value is x0 plus 3h. Similarly x4. So if you observe here all the values of x, then whatever suffix is there, now look at here x4. Suffix is 4. Then here multiple of h is also 4. So in general, when we generalize it, we can generalize it like this. Here it is 4 and multiple of h is also 4. So as a generalization, when we have to find value of xn, then directly we can write down it is x0 plus nh. No need to find all the values. So especially suppose if x0 and h is given and the question is that find value of x6, then immediately you can find value of x6 as x6 equal to x0 plus 6 into h. This is the concept of equally spaced, equidistant or equidistant values of x. And as we define now the function, here function of x. So if you consider all these equidistant values of x, then the corresponding values of y, which will we get after calculation, that are the values of the function at these equidistant points, which we use it in the interpolation. Most of the times you people have given the sets of values of x as well as y if the function is not defined. But if the function is given, then we have to find that values manually. So next topic will go. So if y equal to fx is a function, then the corresponding values of y at x with equal increment h are given as, let us prepare the table for this. So let us see this table. So here we have calculated values of x. Now we are calculating values of y's at this corresponding x. So look at here. Here you have given initial value as x and increment is h. So first value is always your x0. Corresponding value of y is denoted by y0. This suffix 0 also goes as a suffix of y so that we can identify the value of y. y0 means immediately we can say that y0 is value of f at x0. That's why use the same suffix of x to y. So y0 is f of x0. Next value of x is x1. What is x1? x1 equal to x0 plus h. So y1 equal to f of x1 and this is equal to f of, but what is x1? x1 is x0 plus h. So as soon as you get x1, no need to use this definition, but as is a theory, I have given it here. Next value is x2, which is x0 plus 2h. So what is y2? So corresponding value will be y2. So what will be y2? y2 is f of x2. Similarly, at x3, we will find f of x3, which is denoted by y3 and so on. So here it is a function. One question, fx equal to x cube plus 2x square minus 3x minus 6 be any function. Prepare a table for values of fx for x0 equal to 1. x0 is what? The initial value. And h equal to 0.5. What is h? h is an increment. Find values of fx for xn where n equals to 5. So also one thing here, always remember that when I say n equals to 5, we have to find total 6 values because we counted it from 0. 0, 1, 2, 3 and the last value is xn. You can see it here. The last value is xn. We have started it from 0. So actually these values are n plus 1 values. So if n equal to 5, we are going to find 6 values. Means we have to find 6 values starting from 0. That is 0, 1, 2, 3, 4, 5. So here is the table. I will elaborate it in the Excel file. You can check it. See what is the function? X cube plus 2x square minus 3x minus 6. See, x cube plus 2x square minus 3x minus 6. So what is our first value? Initial value you have given x0 equal to 1. And the increment we have given h equals to 0.5. So the first value is x0 equal to 1. Then what is y0? So again we will use the same method that wherever there is x, we will substitute x equal to 1 in the formula of fx. What is the formula of fx here? X cube plus 2x square minus 3x minus 6. So you can see on the screen here that I have substituted x equal to 1, so that is 1 cube. Then 2 into x square, so 2 into 1 square minus 3 into 1 minus 6. So calculate this properly, you will get answer minus 6. Now next value x1, we have to find. It is not given to us. We have given only x0 and h. So now next value we will find. So what is x0? 1. And what is increment? That is 0.5. So actually x1 is what? X0 plus h. We have seen in the theory that what is x1 always? X0 plus h. So here it is 1 plus 0.5. I'll write here. So what is x0? x1. I'm sorry. x1 equal to x0 plus h. That's what we have this value as 1 plus 0.5, which is equal to 1.5. So same way we have done it for all these values using this formula here. Okay, this formula. So value of x1 is 1.5. Now we will find value of the function at x equals to 1.5. So at x1, value of the function corresponding to x1 is y1. So what is y1 now? Again we will substitute value of x in this formula. So here 1.5 cube plus 2 into 1.5 square minus 3 into 1.5 minus 6. So doing this calculations here, we will get finally it is minus 2.625. Similarly, for x2, what is x2 now? x1 plus h. This is a formula here. x1 equal to x0 plus h means x2 equal to x1 plus h. So what is my x1? x1 is 1.5. What is my h? 0.5. So what is the answer? 2. So what is value of x2? It is 2. So again by the same method we got value of y2. Here it is y2. Okay. Now same. Next x3. What is x3? x3 equal to x2 plus h. x2 is 2. H is 0.5. So your x3 is 2.5. So now at this 2.5 means value x3, we will find value of y3. Same for x4, you can check it. So x4 is x3 plus h and it is equals to 3. So we will find, here we have got value of y4 by substituting it in the formula, same as x5. So as in the question we have asked find values for xn n equals to 5. So finally you must have here n equals to 5. So if you count all these numbers, then how many values? This is 1, 2, 3, 4, 5, 6. So all total there are 6 values. So we will get 6 corresponding values of y's. These are called the values of a function at equally spaced values of x. Why these are equally spaced? Because we have this equal increment h equals to 0.5 and we are getting the next value by adding 0.5 to the previous one. Therefore, these values are called equidistant values of x and these y's are called the values at, these are actually the equally spaced points. Equally spaced means having specific increment here. We should have to differentiate this equally spaced and unequally spaced here, because there are different formulas which we are using in this interpolation. For equally spaced we are using Newton's forward interpolation formula, and for unequally spaced points we are using Lagrange's interpolation formula. We can use Lagrange's interpolation formula for equally spaced also, but Newton's forward interpolation formula is only we can use for equally spaced points. So today's lecture here. Tomorrow we will see operators, forward difference operators and its applications, and how to construct the forward difference table. Thank you.